let's take a look at question 12 first. Okay, for question 12, right, we have ABC, a triangle in which the points A, B, and C are given. First in part I, we found the area of the triangle, and then after that, we found the lengths of AB and AC. So let's imagine what the triangle looks like first. Okay, so with the points, it will probably look something like that. Okay, so in part I, we already found that the area is 5 units squared. And then in part 2, AB is square root of 5 units and AC is 5 units. Okay, so this means that down here is square root of 5, AC is 5. And what we want to find is the sine of angle BAC, which actually is the angle here. Okay, and it is the included angle, alright, for the two lengths that we have already found. Okay, so what we can do is to make use of part I, where we have the area. Okay, then after equate it with half times A B sine C formula. Okay, so we make use of the length square root of 5 and 5. Right, then we manipulate and we will be able to get sine of angle BAC to be 5 divided by half divided by square root of 5 divided by 5. Okay, therefore we would get 5 divided by half is 10 divided by 5. We would be getting 10 over, this is 10 square root 5. We will have 2 over square root 5 here. So 2 square root 5 over 5 if I rationalize the cert. Okay? Well, except if you didn't rationalize the cert, right? Question actually wants it, question wants it to be a rationalized form. So therefore, you rationalize it by multiplying the square root of 5 over 5, and you get the answer 2 square root 5 over 5. Okay, and that's how you show it. Yes? That will be a bit too inefficient. Yeah. Okay. If you want to go ahead and prove that it is a right angle triangle, then actually wait. I wouldn't accept it if you prove the triangle is right angle, because you didn't use the results in part I and part 2. Yeah, question specifically say use the results in part I and part 2. So this should have been the process for yourself to answer. Okay. Next, question 13. Okay, for question 13, the points A, B, and C are the vertices of a triangle. Given that the area is 80 units squared, we want to find the possible values of K. So we map out these points on the axis itself. So we have 3, 5. And then B is negative 5, 9. And for C, we know that it is K and K plus 2. So actually, we have no idea where this C would actually be. Right? There isn't any guide at all. So what we can see is that C could actually end up on top here. Okay. Or else we can have it at the bottom. Okay. Somewhere here, perhaps. Alright, so making use of this two diagrams, these two different cases, we will form the equation. So if C is above AB, the line AB, then going in a clockwise manner, we will have 3, 5, K plus 2, negative 5, 9, and 3, 5 again, which equates to the area 18, right? after we do a shoelace method, we would get 3k plus 6 plus 9k minus 25 minus 5k plus 5k plus 10 minus 27 equals to 18 plus 2. So, like 12k, this is negative 19, negative 9, negative 36. So k will be equals to 6, right, for the first case. And then we have to do it for the second case as well. So it is the same thing. Going in an anti-clockwise manner, we have 3, 5, negative 5, 9, k and k plus 2, and 3, 5 again, to equate it to 18. Okay, I leave that to you to actually open it up with the shoelace method. Is that possible? Then part 2, hence find the height of the triangle ABC for which the base is AB. So regardless of the case of where the C actually is, the height will actually remain the same. Alright, so long as our AB is the base. Okay, so since the area is actually 18, we need to first find out what is the length of AB. So AB will have the length square root 80. Then after that, we let the height be h. So half times square root 80 times h is 18 because the question says area is 18. Then by doing some manipulation, we would get square root 80 can be a simplified set of 4 square root 5, right? You should definitely have the habit of simplifying your set, okay, because we have already learned how to simplify it, right? You should take every opportunity to practice simplification of sets. And we have equals to 9 square root 5 over 5, and that will be the height. Sorry, what do you mean?
We don't find the exact value.
We don't find that. What do you mean by that?
Exact value.
This is the exact value. What do you mean by we don't find the exact? I don't quite understand what you mean.
I think the exact value.
It's 3SF is not exact value. This is the exact value. Okay. You can find 3SF or you leave your answer in exact, that will be fine. Right? In AMAX, you can leave your answer in cert form, not an issue. Okay. In EMAX itself, 3SF will be preferred. Okay. For question 14, may I know which part for question 14 is actual? Which part for question 14? Everything? Okay, when it says everything then, let's just do everything then. But when it says part 4, okay. Let's take a look at it. Quadrilateral OPQR. Coordinates of P is given. The length of OP is actually 6 square root 5 units. Okay, we want to show that A is actually equals to 6. Alright, so since we're given the length here, okay, we can use the length of line segment formula because O is actually the origin 0, 0, right? So the length of the line segment would be square root of A minus 0 squared plus 2A minus 0 squared equals to 6 square root 5. Okay, you can think about it by applying the length of line segment formula. Otherwise, okay, you can see as though it's a right angle triangle, which is also possible to get. So the same logic will still apply. Okay, then we will get A squared here plus 4A squared. Okay, and then we square the other side. This will give us 36 times 5, which is 180. So A squared would be 180 divided by 36. Okay, so A is equals to 6 or negative 6. But since question says that A is actually positive, that is the reason why we reject the negative value of A. Okay, because A is more than 0. Right? Then part 2. Part 2 went on to say that PQ is perpendicular to OP and Q lies on the y-axis. We want to find the equation of PQ. Okay, so to find the equation of PQ, okay, so PQ being perpendicular to OP, will we be able to get the gradient of OP first? Wayne, can you find for me the gradient of OP? Tell me how to find the gradient of OP. A is already 6, so these coordinates will actually be 6 and 12. So gradient of OP is just tell me the calculations that you need to make. Huh? Gradient of OP, yes. Yeah, so what is the gradient of OP? 2. Huh? OP is this one. How to find the gradient of OP? We got O coordinates, you got P coordinates. Sorry? 12 minus 0 over 6 minus 0, so that gives us 2. Okay, so the gradient of PQ will be equals to negative 1 over 2. Okay, negative 1 over 2. Right? Then we have the gradient already. So to find the equation, since we got this point, it will be y minus over 12 equals to negative half bracket x minus 6. So y minus 12 equals to negative half x plus 3. Y is equals to negative half x plus 3 plus 12. We have 15. Right? Then part 3, to find the coordinates of Q, okay, we will have to simply take x equals to 0. Because Q is on the y-axis. Okay, so we see Q is equals to 0, 15. Otherwise, you can recognize that Q is actually the y-intercept value of the line PQ. So the y-intercept value is 15. We can directly get the coordinates of Q as well. Okay, so actually working is not entirely necessary. In part 4, okay, we want to find, or rather we are given the point R lies on the perpendicular bisector of PQ. Okay, so let's draw in the perpendicular bisector. Okay, I'm not going to get a very accurate diagram. So R is on the perpendicular bisector of PQ. Given that the line OR is actually parallel to the line, so this one here is parallel to another line, okay, that has an equation 11x plus 2y minus 4 equals to 0. I'm not sure where this line is supposed to be. Actually, if you go on to manipulate, the line should probably be on top. But it doesn't matter. Okay, so we want to find the coordinates of R. So let's go about finding the equation of the perpendicular bisector first. Okay. Alright, so to find the equation of the perpendicular bisector, we need to find the coordinates of the midpoint. Okay. So coordinates of midpoint of PQ would be, this is 0, 15. So we have 0 plus 6 over 2 and 15 plus 12 over 2, which is 3 and 25, 827, so we get 113.5. Okay. Then we need to find the gradient of the line PQ, but we already had it, which is half, negative half. So the gradient of the perpendicular bisector would be equals to 2, actually. Okay, so equation of the perpendicular bisector would be y minus away 13.5 equals to 2 times x minus 3. Would be 2x plus 7.5 for the equation of perpendicular bisector. Okay. So we now have the equation of this already. Our main aim is to find the coordinates of R, which is the intersection point between the line OR and the perpendicular bisector. Okay, so the next thing is to actually find the equation of the line OR. Right? How do we find the equation of the line OR? How should we find the equation of the line OR? Jared, what do you think? Yeah. Jared, how do we find the equation of the line OR? Sorry? Find the gradient of this line of OR. How? I wish that your hand is the laser pointer. 11x plus 2x. So find the equation, find the gradient of this line. Yeah. Okay, so we find the gradient, of the line 11x plus 2y minus 4. So gradient of OR equals to 11x plus 2y minus 4 equals to 0. Okay, so we manipulate it into the form y equals mx plus c. since that line is parallel to OR, the gradient of OR would actually be equals to negative 11 over 2. And since it is OR, we have this point here. So the equation of OR would be y minus 0 equals to negative 11 over 2 x minus 0. In fact, any line that passes through the origin will have the y-intercept to be 0. So that's why the equation of a line that passes through the origin will simply just be y equals to the gradient times x. Okay? Now that we got those two settled, we will solve simultaneously. Solve these two equations simultaneously, and we have negative 11 over 2x equals to 2x plus 7.5. And we have this is negative 5.5 x minus 2x equals to 7.5. So therefore, the coordinates of R will be negative 1 and 5.5. Okay, then part 5, to find the area of OPQR, we have actually found all the points already. We will use shoelace method to solve accordingly. So you can start at any point that you want, as long as you go in the anti-clockwise manner. I'll leave it to you to do the shoelace. Your final answer should be 52.5 units squared. Are there any questions? Yes, answer. How do I get the gradient of perpendicular bisector? Because perpendicular bisector is out of two parts, perpendicular and bisector, right? Bisector helps us to get the point, the midpoint. The idea of perpendicular, okay, will give us the gradient, because when we know the gradient of PQ, the gradient of the perpendicular bisector will be negative 1 over the gradient of PQ. So, because just now earlier on there was this working over here that says that the gradient of PQ is actually negative 1 over 2. Yeah, that was that working just now when I did it. Yeah, I don't know whether I managed to catch it. Okay, I think I did that working in part 2. Yeah. Part 2 when solving to find the equation of PQ. Yeah, okay. In fact, what you can also see is that this perpendicular bisector confirm must be parallel to PO also. Cannot be these two lines perpendicular to the same thing, but then the gradient different. Doesn't make sense, right? Any questions? Okay, if no questions, please submit your homework to the front. We're going to cover binomial today. Actually, can you stop the video and then start again? Thank you. When I start the binomial later.